Hi, and welcome back to the Implementing and Administering Cisco Solutions, the CCNA 200-301 video series course by EC Council. My name is Glenn Singh. In this video, we'll be configuring an IPv4 static routing lab. So let's actually get the lab file so you don't have to build from scratch. As you probably are familiar, visit my GitHub and ensure that you're in the code red CCNA 200-301 folder. Click on domain tree IP connectivity and simply download and open lab 1, which is called IPv4 static routing. Simply download it and open it with Cisco Packet Tracer. Once you have opened the lab, it should look like this. So here we have an organization. We have an HQ, which is the headquarters location, the HQ LAN, and we have two branches, branch A, branch B, and they are connected using a Metro Ethernet circuit. And we also have the internet connection that is connecting to the HQ router. So typically, if we just break down the organization network, we have branch A and branch B, and we have HQ up here. And each branch is connected something like this, but we actually have a Metro Ethernet connection. Now, this here is a typical hub and spoke, which means if branch A wants to communicate with branch B, the traffic must go to HQ, and then HQ would send it to B, and vice versa. So even though we have a Metro E circuit, we could actually emulate that effect, such as, let's say, PC1 wants to speak to PC2. Well, we could have branch A router here send traffic to the HQ network, and then the HQ network send it to branch B, and vice versa. Rather than we have HQ send it directly through the WAN link like this, no, we actually want to do it like this. So each branch speaks directly to the HQ router. So that's one thing we want to do. So what we'll do for that is we'll set up default routes on these branch routers here, and we'll set up network static routes on the HQ router to actually send traffic to both of these branches individually. And most importantly, we'll set up a default route on the HQ router to send traffic to the internet should traffic need to go to the actual internet. So let's actually begin. We can start with the HQ router. So let's simply click on the HQ router. And let's drag this a little bit across here so you can get enough real estate. And let's widen this window a bit more. Click on CLI and let's press enter twice. Currently, if we check our routing table, like so, you will notice that the routing table does not have routes for, let me draw this a little bit here. It does not have routes to reach 172.1.1.0/24, which is branch A network, and it does not have any route to reach 172.20.1.0/24, which is branch B. And that is a major problem. So what we can do is we can install network routes on HQ right now. To do this, we need to go into global configuration mode. And now we need to use the iproute command. So let us first configure HQ to reach this branch network. To do this, we can use the iproute command. Then we specify the destination network, which is 172.16.1.0. Then we specify the subnet mask, which is 255.255.255.0. And here we could specify either a fully qualified route, such as our exit interface and next hop IP, or just the exit interface, or just the next hop IP. For security reasons, let us use a next hop IP. So next hop IP is the IP address on this interface right here, which is 10.2.1.10. So let's enter that right here and hit enter. And that's it. We actually set our route for the HQ network to reach branch A. So let's configure a network route to reach branch B as well. And let us check our routing table one more time to verify the route has been installed. And as you can see here, we actually have this static route, which is to reach branch B, administrative distance of 1, metric 0, and our next hop. We also have another static route to reach branch B's network. And looking at the administrative distance, we know it is a static route and a next hop IP. Now the thing is, if the PC that is located on HQ network here is trying to reach any of these PCs, like let's say this one or this one, what will happen is the ping will go across, but it will not come back. So therefore, this computer here will experience something called a request timeout, simply because branch A router do not have a path to actually reach back to the HQ network. And that's actually a problem. So let's actually investigate that right now and see what happens. So let's click on this PC across here on HQ network, and let us attempt to ping the PC which is on branch A, which is 172.16.1.10. And you'll see that we will be getting request timeouts. This simply means that a packet is going, but it's not getting a return message. And we can actually validate why in just a bit. So when we looked at the HQ network just now, the HQ router actually has network routes to each of the branches. So you could see this here is branch, actually not that one. This one is branch A, and this here is branch B's network. But let's check the routing table within branch A network, within branch A router. And notice that within branch A router, there is no network or any route that is pointing back towards the HQ network. So that's why we were getting request timeout. Now remember, with branch A and branch B, we want to send all our messages directly to HQ and HQ forward it to the remote branch. So to do this, what we can do in branch A and branch B is we could install a default route that will always point towards HQ router. So to do this, let's go in global configuration mode. And let us use our default route command, which is IP route and 0.0.0.0 space, and the subnet mask is all zeros as well. And we can specify the next hop, which is the IP address on this interface of HQ, which is 10.2.1.5. And that's it. Therefore, if branch A receives a packet that a route does not exist within the routing table, it will forward it to the default gateway. So let's actually check the routing table one more time. And looking closely, we actually have a gateway of last resort, which is configured on branch A. The gateway of last resort is this interface here, well, this one here, on the HK router. And what this means is if branch A router receives a packet that it does not have a route for, it will simply forward it to the actual gateway of last resort. Let us configure branch B router with the same default route as well. Let us verify the route has been installed within the routing table. And here we can see the gateway of last resort is the actual IP address on HK router on its gigabit Ethernet 0/0 interface. So this means that if branch B wants to send a message to this network here, remember this network does not exist in the routing table. So what will happen? Well, it will use the default route, which will be 0.0.0.0/0, and the next hop IP address, in other words, the gateway of last resort, it will simply forward it to the HK router, and the HK router will take it from there. But while we are here one time, let us configure a default route on HK router to point towards the internet. In reality, the internet service provider will give you a next hop IP address to use. But for this lab exercise, we are going to use 192.0.2.1 as the ISP IP. Alright, and if we do a show IP route within HK router, we should have a gateway of last resort installed within the routing table. And here we have the gateway of last resort, which is the internet route. Now, let us test our entire network properly. So let's head over to the PC located in, let's say, branch A. And let us try to ping the PC that is located in the HQ network, which is this computer right here. And it is working. Let us do a trace route now to the same computer. As you can see, the PC had sent it to branch A interface. Then branch A forwarded to the HQ IP address, which is this one right here. And then the final hop is the actual destination PC. But let's actually test the internet from right here. And let's see if we could reach this server. And this server is located on the internet. And let's ping one more time. And we are able to reach a server on the internet. And let's do a trace route to validate this information. And these here actually show you the path the packet took to actually reach to the actual server on the internet. So if we actually trace it, the PC will use this as a gateway, which is branch A router. Branch A gateway is the HQ router. Then HQ gateway is the ISP router. And the ISP will eventually forward it to the destination server. And the traffic will return using the same path. In this video, you have learned how to implement IPv4 network routes. You have also learned how to configure IPv4 default routes to the internet. And you have learned how to perform basic troubleshooting commands to verify connectivity. In the next video, we will take a look at configuring IPv6 static routing. I hope this video has been informative for you, and thank you for viewing.